Capture the spirit of the holidays like never before with Rockbrook Camera, Nebraska and Western Iowa's premier camera store since 1975. Rockbrook Camera has the latest cameras and lenses, so you can preserve precious memories and learn new photography skills that will last a lifetime. Let the knowledgeable photography pros at Rockbrook Camera show you how to take great pictures of family traditions, the kids' sporting events, and the kids' big holiday musical. Rockbrook Camera is always ready to help with amazing customer support. Join one of their photo classes to learn the best tips and order a beautiful, custom-made gift from their photo lab. Capture the beauty and majesty of winter's snowy landscapes. Be prepared for holiday gatherings and be ready to capture all the family fun. Visit Rockbrook Camera today, 1 block south of 168th and West Center in Omaha, 70th and Pioneers in Lincoln, or online at rockbrookcamera.com. Rockbrook Camera. Great photography begins here.
Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You could even call your aunt who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. US Cellular, built for us. Visit your US Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
This is SpaceTime, Series 23, Episode 41, for broadcast on the 4th of May, 2020. May the 4th be with you. Coming up on SpaceTime, Centaurs identified as permanent interstellar visitors to our solar system, keeping track of Bepi Columbo, and new vision revealing more Iranian rocket secrets. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers believe they've identified the first known permanent population of asteroids originating from outside our solar system. The 19 asteroids belong to a group known as Centaurs, a population of ancient rocks circling the Sun in the outer solar system amongst the orbits of the gas and ice giants, Jupiter, Saturn, Uranus and Neptune. Centaurs appear to have characteristics of both asteroids and comets, and they have very unstable dynamic orbits caused by the gravitational perturbations of the giant planets they're associating with. Some of them are thought to only have lifespans of a few million years. As well as the giant planets and their moons, Centaurs also have to navigate between the Jovian Trojans, the Neptunian Trojans, Kuiper Belt objects, and scattered disk objects. Astronomers estimate there are somewhere between 44,000 and 10 million Centaurs, a kilometre or more in diameter, in the outer solar system. The largest confirmed Centaur is 10199 Chariklo, a 260 kilometre wide object with its own ring system. The 19 newly identified potential interstellar Centaurs are believed to have been captured from other star systems billions of years ago and have been orbiting our Sun in disguise ever since. The first confirmed interstellar visitor to our solar system was the asteroid Oumuamua, discovered in 2017. Its speed and its hyperbolic trajectory means it could only have originated from outside our solar system, and therefore must have come from another part of the galaxy. But it was already on its way back out again by the time it was identified. Then, late last year, a second interstellar visitor, the comet Borisov, was identified, also by its speed and trajectory. It's now become the centre of intense study, as volatile gases boiling off the comet are providing new insights into its chemical composition and therefore the chemical composition of other star systems. But it too is only a temporary visitor. After swooping around the Sun in December, it now also is on a course back out into interstellar space. However, this newly identified collection of potential interstellar asteroids are thought to have been present in our solar system virtually since its birth 4.6 billion years ago. It works something like this. Stars are born in vast stellar nurseries, deep inside molecular gas and dust clouds. And as it forms, each star has its own planets and asteroids. But they're not formed alone, but rather close together with lots of siblings. And being so close early on meant stars were constantly pulling gas and early protoplanets and asteroids away from each other, a process that would continue until the stars began to drift apart and make their own way through the galaxy. The new findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, are based on numerical simulations which have turned back the clock to the earliest days of the solar system, producing a sort of snapshot that allowed the authors of this paper to see where these groups of asteroids were originally located. And the computer simulations suggest that at the time of the snapshot, these specific 19 Centaurs were orbiting the Sun in a distinct region beyond the reach of the original solar system planetary disk. And also, they were moving perpendicular to the orbital plane shared by the planets and other asteroids. The new findings follow research back in 2018 by the same team of authors, which suggested that one particular Centaur, 514107 Kapolka Awela, may also be of interstellar origin. The 3-kilometre wide asteroid is in a resonant co-orbital motion with Jupiter, and its orbit is retrograde, meaning it's circling the Sun in the opposite direction to most other bodies in the solar system. And the author's initial computer simulations suggest that it, too, could be of interstellar origin. As well as providing a more complete picture of our solar system, the new study also provides new clues about the Sun's early birth cluster, how interstellar asteroid capture could have occurred, and the role that interstellar matter has played in chemically enriching our solar system and shaping its evolution. This is SpaceTime. Still to come, a 2-kilometre wide potentially hazardous near-Earth object has just flown past Earth's space, luckily at a safe distance, and keeping track of the European Space Agency's Mercury-bound probe Bepi Columbo. All that and more still to come on SpaceTime. A 2-kilometre wide potentially hazardous NEO, or near-Earth object, has just flown past Earth's space. The mountain-sized asteroid called 1998 OR2 passed safely at a distance of 6.3 million kilometres, more than 16 times the distance between the Earth and the Moon. Its closest approach to Earth was above the Great Barrier Reef. Asteroid 1998 OR2 was discovered by the Near-Earth Asteroid Tracking Program at NASA's Jet Propulsion Laboratory back in July 1998. And for the past 2 decades, astronomers have been keeping a close eye on it to see what sort of threat it poses to the Earth. They've concluded there's virtually no possibility of an impact with the Earth in the next 200 years. Bit of good news there. Its next close encounter with Earth will be in 59 years' time, in 2079, when it will pass a little closer than what it did this time, only about 4 times the Earth-Moon distance. Despite this, 1998 OR2 is still categorized as a large, potentially hazardous asteroid. That's because over the course of thousands of years, very slight changes in the asteroid's orbit could cause it to present a far more hazardous threat to the Earth than what it does now. This is one of the reasons why astronomers have been tracking it so closely during its current close approach, using both telescopes and especially ground-based radar to keep an eye on it. These observations will enable even better long-term assessment of the hazards posed by this giant space rock. Mind you, close approaches by large asteroids as big as 1998 OR2 are rare. The last time something like that happened was the asteroid Florence back in September 2017. It was about 5 kilometres across, but luckily it flew by at some 18 times the Earth-Moon distance. On average, astronomers expect asteroids of this size to fly past our planet roughly once every 5 years or so. And since they're bigger, asteroids of this size tend to reflect more light than smaller asteroids do, and are therefore easier to detect with telescopes. In fact, astronomers estimate that they've already identified about 98% of all near-Earth asteroids the size of 1998 OR2 or larger. But of course, that means there's still another 2% out there hiding in the darkness of space. And then there are the heaps of asteroids smaller than 2 kilometres across, which are yet to be discovered. Pleasant dreams. This is SpaceTime. Still to come, keeping track of the European Space Agency's Mercury-bound BepiColumbo spacecraft. And the release of new vision has allowed experts to get more details about the secrets behind Iran's rocket program. All that and more still to come on SpaceTime. As the European Space Agency's Mercury-bound BepiColumbo spacecraft undertook its 30 km per second flyby of the Earth the other week, scientists with the University of Western Australia were keeping a close eye on it, just to make sure things went according to plan. The Earth flyby was the first of 9 gravity-assist manoeuvres BepiColumbo needs to undertake during its 7-year journey to reach the planet closest to the Sun without being overwhelmed by the Sun's enormous gravitational field. So, while most gravity assists are designed to slingshot a spacecraft to a faster speed, this one was designed to slow down the probe from 30.4 kilometers per second down to 25 kilometers per second as it swooped down over the South Atlantic Ocean at an altitude of just 12,677 kilometers. Still to come are 2 flybys of Venus, then 6 of Mercury, before the spacecraft will finally be able to enter orbit around the sun-scorched planet. The University of Western Australia team worked closely with BepiColumbo mission managers in Europe to provide continuous imaging of the space probe using the Australian Research Council's Centre of Excellence for Gravitational Wave Discovery, or AUSGRAV's, Zadko telescope in Gingin. Mind you, the task was made a little bit more difficult because of the COVID-19 lockdown restrictions, forcing the telescope controller, Bruce Gendry, to operate the telescope remotely from his home in the Perth suburb of Claremont. As well as keeping track of BepiColumbo, the flyby also provided a useful test for the European Space Agency's Planetary Defence Office, allowing it to test its capabilities to coordinate the observation of future potentially hazardous near-Earth objects, something difficult to do in the Southern Hemisphere because of a lack of suitably sized telescopes. BepiColumbo was launched aboard an Ariane 5 rocket in October 2018 from the European Space Agency's Kourou spaceport in French Guiana. The spacecraft is made up of 4 sections. There's the European Space Agency's Mercury Planetary Orbiter, which is designed to analyse the planetary surface and composition. Then there's the Japanese Aerospace Exploration Agency's Mercury Magnetospheric Orbiter, which will explore the planet's magnetosphere. These 2 orbiters are designed to circle the planet at different altitudes. A 3rd section is the Mercury Transfer Module. It's located at the base of the stack and supplies power and support to the 2 orbiters, as well as propulsion during the cruise phase of the mission, and it helps protect the orbiters from the extreme temperatures as they get closer to Mercury and the Sun. The 4th section is the Magnetospheric Orbiter Sun Shield and Interface Structure. It's fitted between the 2 orbiters, and it will provide additional protection for the Mercury Magnetospheric Orbiter before it enters orbit. BepiColumbo is slated to achieve Mercury orbit insertion on December 5, 2025. Once in orbit, it'll study the planet's structure, its magnetic fields, the surrounding near-space environment, the planet's interaction with the near-solar environment, and the solar wind. Mercury is the smallest and innermost planet in the solar system. It has a diameter of 4,480 kilometers at the moment, more on that later. Its highly elongated orbit around the Sun takes just 87.97 Earth days, the shortest of any planet in the solar system. And Mercury rotates in a way that's unique in our solar system. See, it's tidally locked to the Sun in a 3-2 spin orbit resonance, meaning that relative to fixed background stars, Mercury rotates on its axis exactly 3 times for every 2 revolutions it makes around the Sun. So, if you were standing on the surface of Mercury, you'd experience only 1 Mercurian day for every 2 Mercurian years. Mercury appears to have a solid silicate crust and mantle, overlying a solid iron sulfide outer core layer, a deeper liquid core layer, and then a solid inner core. Scientists estimate that Mercury's core occupies some 55% of the planet's overall volume. Now, that's quite a lot, considering the Earth's core, outer and inner, only make up about 17% of the Earth's total volume. One hypothesis to explain Mercury's proportionally large core suggests a planetary collision billions of years ago, which stripped away most of the planet's original crust and mantle. In fact, possibly as much as half of the planet's original mass. It's not the only hypothesis to try and explain the planet's large core, but you gotta admit, it's the most spectacular one. Mercury's surface features extensive mare-like plains and heavy cratering, very similar in appearance to the Earth's moon. And that all indicates that the planet's been geologically inactive for billions of years. One unusual feature of Mercury's surface is its numerous compression folds or roops that crisscross the plains. As Mercury's interior cooled, it contracted and its surface began to deform, creating wrinkle ridges and lobate scarps associated with thrust faults. These scarps can be over 1,000 kilometers long and some are up to 3 kilometers high. And they can be seen on top of other features such as craters and smooth plains, all of which indicate some of them are fairly recent. Surface mapping suggests the planet's already shrunk by about 14 kilometres in diameter, and is continuing to shrink today. The Lunar Reconnaissance Orbiter discovered similar small thrust faults on the Moon, another thing the Moon and Mercury have in common. And again, like the Moon, Mercury has almost no atmosphere, and therefore an inability to retain heat. In fact, Mercury's surface temperatures vary diurnally more than any other planet in the solar system, ranging from a scorching 427 degrees Celsius in the daytime down to a freezing minus 173 degrees Celsius at night. Gendry says, as well as improving science's understanding of the planet Mercury, the BepiColumbo mission will also offer new insights into how the Earth and solar system formed. He says the Zadko telescope was put into play to help monitor the mission following a request by the European Space Agency.
The Earth flyby is due to the fact that when you launch a probe to visit another planet, you need a lot of propellant. And in the case of inner planet, which means Venus and Mercury, you mean also to translate a lot of potential energy, something that you have due to the fact that you are on Earth, into kinetic energy and then dissipate that thing. So all of it request a lot of propellers, and propellers, it's heavy. So when you want to launch that, you need to basically have a big rocket that costs a lot of money. So the best solution to avoid that is to use gravitational assistance, and first to do flybys of planets.
Why is Mercury so hard to reach? Why is it so difficult?
Basically, it's just due to the fact that you don't have as many funds as you had before in the 60s and the 70s when you are launching probes. Technically, it's not that difficult. If you put a lot of propellers, you can reach it very fastly. The difficulty is that if you don't, the gravitational assistance is not something which is extremely powerful. It is powerful, but not to that point. So that means that you need to have a lot of flybys. In the case of BepiColumbo, you will have one flyby from the Earth and then several from Venus and from Mercury before reaching the final destination.
How did the University of Western Australia undertake these observations, and why?
In order to gain the maximum from the gravitational assistance, you need to burn some of the propellers before reaching the lowest point of the flyby. And basically, that means that all the maneuvers that you have to do were a couple of hours before that. At that time, Australia was right below the probe when it started. And we were able to follow nearly up to the closest point when everything is stopping. So that means that we are at the best place in order to make the observations. And they contacted us because we were already in contact through another program that we have, which is supposed to monitor the Earth to be sure that the neighborings of the Earth is safe for impactors. Basically, small bodies or a couple of kilometers bodies that could threaten life on Earth that need to be monitored. And we are part of a program that are there so that if we detect something, we make observations and that give precise position of the orbit in order to tell if it's safe or not. So we had the possibility to do exactly the same thing with the probe because it was large enough.
Okay, and the flyby, it changed the spacecraft's velocity from 30.4 kilometers per second down to around 25 kilometers per second without the need of any fuel. That's what it's all about, I guess, as you said earlier.
You just needed to change a little the mass of the system so that you have a small change in the mass of the global probe. So that means that you will have a minimal burning of fuel during that time, and that will be enough in order to make the things. The gravity of the Earth will do this very main.
Basically free energy.
It's not completely free. Technically, the Earth has gained some energy and increased its velocity. But seeing the size of the Earth, this is something that would never be measurable.
We won't notice it.
It's an exchange of energy.
What about the mission itself?
So the mission has been designed and decided in the late 90s. So at that time, the only thing that we are knowing about Mercury was what Mariner 10 has made, so a couple of images, and a measurement of the magnetic field, not that much. So the probe has been designed in order to study the magnetic field, in order to understand how the planet will interact with the solar wind. We'll also study the geology of Mercury. We'll make a lot of pictures in order to have a better coverage of the surface. There are some gravity measurements They will test the general relativity to be sure that it's working, I would say. There are other small probes, things that will be done at the same time. The only thing that we will not do, technically, is that there is no lander, because it was too heavy for the mission.
That's Dr. Bruce Yendry from the University of Western Australia. And this is Space Time. I'm Stuart Gary. Still to come, new images of last week's Iranian rocket launch are providing more details about the test and exactly what really happened. And later in the science report, we look at all the available data on how the COVID-19 virus infects the human body. All that and more still to come on Space Time. New images of last week's Iranian rocket launch are providing more details both about the test and also about what really happened. Now, as you remember in last week's program, we raised suspicions over Tehran's original claims that the Gahast or Messenger two-stage rocket was used for the flight. Well, it turns out those suspicions were justified. The new images clearly show the launch vehicle wasn't a Gahast as claimed by Tehran, but it was actually a Shahab-3 long-range ballistic missile, the same sort of launch vehicle we had seen in these types of tests before. As we pointed out in last week's show, the Gahast is actually a short-range air-to-surface missile, usually launched from fighter jets towards ground targets. And so the use of such a missile on an orbital launch system always seemed a bit strange. The Shahab-3 is an Iranian copy of North Korea's No-Dong ballistic missile series, which itself is based on old 1980s-era Soviet Union Scud missile technology, but equipped with a newer upgraded 40% larger Scud rocket motor, which was being developed by Russian scientists when the Soviet Union collapsed. Pyongyang provided the scientists and their rocket engine designs with a new communist dictatorship to call home. The new images show an exhaust plume whose colour suggests the launch vehicle's Shahab-3 first stage is fueled by unsymmetrical dimethylhydrazine propellant and an oxidizer composed of nitric acid with 27% dinitrogen tetroxide. The launch vehicle's second stage is based around the new domestically developed Salman solid rocket motor, and it's being seen with some trepidation by defence experts, as it's likely to be the first step in developing a far larger solid rocket booster. Little's known about the third stage of the rocket stack, other than it's liquid-fueled and equipped with 6 bipropellant reaction control thrusters. The combined rocket stack blasted off from a mobile launcher from the Islamic Revolutionary Guard's Sharud missile range, 330 kilometres northeast of Tehran. The launch placed Iran's new Nor-1 spy satellite into a 425-kilometre high low Earth orbit. Initial reports suggested the satellite was a 3-unit CubeSat. Images show it's actually a 6-unit CubeSat fitted with a high-end webcam. And that in itself is interesting because as a spy satellite, it wouldn't provide images of the ground that are as good as what's already available from several commercial Earth observation satellite operators. And it suggests that the real purpose of the flight was to test the new missile stack, especially the new second-stage solid rocket motor. The flight was in clear violation of Iran's 2015 anti-nuclear agreement with the United Nations. US Secretary of State Mike Pompeo criticized the launch, describing Iran's space program as nothing but a cover to develop ballistic missiles, the same tactic used by Iran's ally North Korea as it developed nuclear weapons and the missile systems needed to deliver them. And as we mentioned last week, it also comes as the International Atomic Energy Agency reports that the Islamic Republic has almost tripled its stockpile of enriched uranium since November, jumping from 372 kilograms up to over 1,021 kilograms, another violation of its anti-nuclear accords. The United Nations nuclear watchdog says Iran now only needs another 30 kilograms of uranium to have enough fissile material to build an atomic bomb. At the same time as all this is happening, the Atomic Energy Agency's inspectors are being refused access to 3 suspected nuclear sites where enriched uranium residues been detected, including one site at Taqwazabad, which Tehran describes as a carpet cleaning factory. Surely the only carpet cleaning factory in the world classified as top secret. This is Space Time. Still to come, the science report, and we look at all the available data on how COVID-19 infects the human body. All that and more still to come on Space Time. And time now for a brief look at some of the other stories making news in science this week with a science report. The world has now suffered almost 250,000 deaths from the COVID-19 coronavirus. And over 3 million people have now been infected with the deadly disease, which spread from the Wuhan wet markets in eastern central China. Now, a new report in the journal Science has combined all the available data on how COVID-19 infects the human body. The data tells us that the virus appears to target ACE2 receptors, which are found in the upper respiratory tract at the back of the throat and nose. While most people will recover and some won't even notice it, others will go on to develop far more dangerous symptoms, with the virus moving through the airways of the lungs into the tiny air sacs or alveoli, another area rich in ACE2 receptors where oxygen transfers into the bloodstream. There, the virus triggers inflammation, dramatically affecting respiration and causing pneumonia, and from there often a rapid downhill slide into acute respiratory distress syndrome. The body's immune system response, trying to fight the virus, goes into a damaging hyperimmune overdrive, unleashing a chemical cytokine storm into the blood, with immune cells even attacking healthy tissues, causing widespread blood clotting, leaking blood vessels, and sending blood pressure crashing. 20% of patients go on to suffer heart damage, possibly because the heart lining's also rich in ACE2 receptors. The blood clots can also trigger strokes, and combined with the low blood pressure, can cause kidney failure, further poisoning the blood, which then affects the brain, causing a whole raft of other problems, including issues with the central nervous system, delirium, and a loss of consciousness. In about 20% of cases, the virus also infects the small intestines, which are also loaded with ACE2 receptors, and where the virus causes stomach problems, nausea, and diarrhea. In the 5 months since the COVID-19 virus emerged and spread around the world, over 1,100 clinical trials have been registered globally, including over 500 randomized control trials. There is currently no known effective treatment for COVID-19. The most common therapeutic agent currently being trialled is hydroxychloroquine, which is currently involved in 24 trials with a potential sample size of over 25,000 participants. That was followed by 7 trials using lopinavir, ritonavir, and 5 trials testing remdesivir. A new study warns that warmer weather in the Northern Hemisphere as summer starts may not curb the transmission of COVID-19. A report in the European Respiratory Journal looking at the spread of the virus found no difference between more sunny, warmer areas and cooler, less sunny ones. Researchers say social distancing and self-isolation remain as important as ever, even as the weather changes. Now, do you remember that German research vessel, the Polar Stern or Polar Star, which has been deliberately locked in Arctic ice since October as part of a study into climate change in the Arctic? Well, it's being forced to leave its station because of the ongoing COVID-19 pandemic. A report in the journal Nature says travel restrictions and flight cancellations have disrupted necessary crew changes on the vessel. The ship is now travelling to Svalbard, where it will change crew and scientists. Expedition organisers hope to refreeze the ship at the same spot in about 3 weeks' time. A new report has found that 56% of kids aged 8 to 12 and 69% of teens aged 13 to 18 are watching videos online every day. Now, America's National Center for Science Education has launched a new program designed to combat online misinformation about climate change and evolution. Tim Mendham from Australian Skeptics says the program's designed to promote effective science communication skills, and teaching kids how to distinguish fact from fiction is essential.
Common Sense Media is a US organisation. They did a survey looking at, surprisingly, how much videos kids watch online. And it might surprise you that teenagers 13 to 18, 69% of them watch videos online every day.
That doesn't surprise me at all, remembering my childhood.
But of 8 to 12-year-olds, 56% are also watching videos online. So
this is all a lot healthier than my childhood. I was like 24/7 I'd sit in front of the box as soon as I got home from school, and I wouldn't leave till Mum forced me to go to bed.
Oh, no, I'd sit in front of the open fire and open up a book of biblical history and things and sit there and read it.
Okay.
And TV was there as well. But basically, there's a lot of misinformation and not peer-reviewed videos. So teachers are trying to understand how to counter a lot of the false information that's out there in videos. And for all the effort that groups like YouTube YouTube and Google, etc., are trying to sort of keep the garbage out of what's posted on their sites. There's still a lot of it out there, and teachers are struggling against this, or struggling to even cope with trying to establish with their students what's good scientific information, what's bad scientific information. There's a group in the US called the National Center for Science Education, which was largely set up to counter creationism, anti-evolution theories, supposed scientific evidence being taught in American schools, which is a lot stronger in American schools than it is in Australia. In fact, it largely doesn't exist in Australia. So this group was set up to counter that, and they waged a number of major campaigns against various textbooks which are sold, which sort of basically discount evolution in favour of fundamental Christian creationism, etc. They then moved on to other areas like climate change, again, which is a big area for misinformation. So they are training and supplying teachers with information as to how to counter a propensity to not believe in science, to not have faith in science, or to actually believe in fake science. It's not necessarily to give them the answers, it's the process which is important, and teaching people critical thinking skills so that they understand how to differentiate. But that means teaching the teachers how to communicate properly. And a lot of teachers come straight from wherever they've come from. They might come from a science background, but they're not necessarily the best science communicators. So that's what this group is trying to do.
Or they could just listen to our show.
Or they could do that, actually.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
With Starbucks Holiday Blend for Nespresso Virtuo, now exclusively at Target, there are even more ways to share the joy. Savor every smooth and festive sip all holiday season with friends and family at home to fill every indulgent day with cheer.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
We've locked in low prices to help you save big store-wide. Look for the locked-in low prices tags and enjoy extra savings throughout the store. Baker's, fresh for everyone.